Okay, this is a video on section 7.2 in your book on graphing polar equations. As far as it goes, there's a lot of different types of polar equations that your book categorizes. Things like circles, lines, limicons, lemniscates, rose curves. There's a lot of them. I'm not going to take the time to do all of them. I'll leave it up to you, given that you'll have your book when you take the exam, obviously, so you'll have the formulas there. I'm going to give you some for homework and just let you practice graphing them out to see how you graph a polar equation in general. And that's all I'm going to do here. I'm going to pick a couple from your book and go through the steps of actually finding points and plotting points and connecting the dots to get your graph. So first off, we're going to graph this one right here. R equals 4 cosine theta. So we draw our axis. As I said before, if it helps, you can actually look online. You can download polar axes with circular coordinates to make it a little bit easier to graph them if that helps. But we can do fine with the XY axis here. So assuming we don't recognize that equation right there as a certain form like the ones listed in your book, just plot points. That's how we graph things. So over here we can say, let's see, I need a theta, and then from theta I get r. This is no different than I take an x and I plug it in and get y, and then you get xy values. Now we're going to plug in thetas and get r values. So let's see, we'll let theta equal 0, and maybe pi over 4, pi over 2, 3 pi over 4, and pi. And one thing I would stress, and you'll see this as you graph them, some of these graphs are symmetric. The properties are all listed in your book. And to a certain extent, once you understand what you're doing, it's up to you how many points you need to graph to see what's going on. Sometimes if there's symmetry, we can only use theta from 0 to pi. If you're not sure about the symmetry, use 0 to 2 pi and just plot points. Sometimes the points you plot don't give you enough information if you don't recognize the graph. Then just pick more angles in between. Like maybe if this doesn't tell me enough information, I can try pi over 3 or pi over 2. I already have pi over 2. Pi over 3 or pi over 6. Different angles in between all these angles to give me more points to connect the dots on. But we'll go with this one for right now. So let's see. If theta is 0, cosine of 0 is 1. 1 times 4 is 4. If theta is pi over 4, cosine is root 2 over 2. This is 4 times root 2 over 2, which is 2 root 2, which is about 2.8. So far this semester we've been using exact values like this for points. You're going to have to plot them now. So throw this into your calculator and get a value out just so you can see what's going on. Let's see, pi over 2. Cosine of pi over 2 is 0, so 0 times 4 is 0. 3 pi over 4. Cosine of 3 pi over 4 is negative root 2 over 2. Multiply that by 4, you get negative 2 root 2, which is about negative 2.8. And then at pi, cosine of pi is negative 1, we get negative 4. And now, we just want to use that as a guide and see if we can figure out what's going on. So let's see. When the angle is 0, my radius is 4. So we'll say this is 4 right here. When my angle is pi over 4, a 45-degree angle, I get 2.8, which essentially, let's see, if this is 4 right here, then 2.8 is maybe right around there. Rough guess. A little further, I think. Maybe right around there. When I get to pi over 2, my radius is 0, which means I'm down here. When I get to 3 pi over 4 at this angle, I get negative 2.8. Remember, negative radius means I flip, which means at 3 pi over 4, I go over here and I get 2.8, which I said was right around there. I don't think that angle is good enough. We'll go with right there. And then at pi, when I get to pi, my radius is negative 4. Negative radius means flip again. So I end up over here and I'm back at 4. And now we just have those points. And you can plug in more points after pi, but it would seem logical that this pattern is going to keep repeating. And essentially what happens is I start here, then I go up here, then I go over here, then down here, then up here, and keep going. And I get a circle, or at least the closest approximation to a circle that I can draw. But if you think about it, well, let's see. If we wanted to do my conversion here, if I wanted to convert that to rectangular coordinates, let's see. I don't have a conversion for cosine theta. I need an r here, so multiply both sides by r. And you get r squared equals 4r cosine theta. R squared is x squared plus y squared equals 4r cosine theta is x. And then if you solve this out, just really quickly, subtract the 4x, you get x squared minus 4x plus y squared equals 0. Complete the square here. X squared minus 4x, half of 4 is 2, 2 squared is 4, plus y squared equals, I added 4 here, so I add 4 here. And then, well, this becomes, when I factor it, x minus 2 squared plus y squared equals 4. And all of you should recognize this. In rectangular coordinates, that's the equation of a circle. The center, x is shifted 2 to the right, so the center is right at 2. The radius, that's r squared, so the radius is 2. And that's what I should get. A circle of radius 2 centered at the point 2, 0. So again, you can graph it in polar coordinates and then translate it to rectangular coordinates to make sure your graph makes sense. The ultimate goal here is this right here. Being able to take thetas, plug them into your equation, find values of r, and then plot those points and sketch the graph. So we have time, we're going to do one more. So let's see, we will do r equals 2 plus 2 cosine theta. And let's see, well, I'm going to graph it, so I need my axis again. And I need some r's and some thetas. So, we'll put theta right here, and r right here. We'll do the same thing as before. Let theta be 0, pi over 4, pi over 2, 3 pi over 4, and pi. And again, we'll use this as a guide. In theory, if the graph is really complex, we might need some more points. But we'll kind of use this and go from there. So now let's see. When theta is 0, cosine of 0 is 1. I get 1 times 2, 2 plus 2, 4. When theta is pi over 4, cosine of pi over 4 is root 2 over 2. Root 2 over 2 times 2, the 2's cancel, you get root 2. 2 plus root 2 is about 3.4. Pi over 2. Cosine of pi over 2 is 0. 2 times 0 is 0. 0 plus 2 is 2. 3 pi over 4. At 3 pi over 4, cosine of 3 pi over 4 is negative root 2 over 2. Again, the 2's will cancel. This is negative root 2. And we get 2 minus root 2, which is 2 minus 1.4, which is about 0.6. At pi, cosine of pi is negative 1. 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. And that's a bunch of weird values there, so throw them onto my graph and see what I get. Let's see. When theta is 0, I get radius of 4, so we'll say that's 4 right here. When theta goes to pi over 4, I get 3.4, which isn't as far, so maybe right about here. When I get to pi over 2, the radius is 2, which is smaller than that, so maybe it's right around here. At 3 pi over 2, the radius is even smaller, 0.6, so maybe it's here. And then when I get to pi, the radius is 0, and it's here. And now we have those points right there. If we can kind of see it, I can connect the dots. then I get something like that. And since these sines and cosine values will be symmetric, I could plot more thetas, but it'll actually work out pretty much the same. And I'll get something that looks like that. Somewhat lopsided because of my inability to draw straight. But we get a graph that looks like this. And if you look at it sideways, it kind of looks like a heart. Not a very well drawn heart, but it looks like a heart. This is actually what's called a cardioid, because it looks like a heart. There are a lot of variations on this. One thing I would point out, again, I'm not going to take the time to graph all of them. You guys will do them for homework and for practice, the same as I'm doing for my in-class students. But essentially, there are a lot of variations of this equation where you have a constant plus or minus a constant and then times sine or cosine theta. When these two are equal, you'll end up getting a cardioid like this. You can move them around, make them go vertical, but essentially if those two values are equal, in some way you'll get a cardioid. Because there'll be a point when your radius becomes 0, which will give me this point. But you can, based off of those values, also push that point further out this way and kind of flatten out this part of the circle, or you can keep pulling it even further inwards. Essentially based off of whether this, if we call it A and that's B, A can be greater than B or A can be less than B. I'm going to leave it up to you guys, just like I did with my in-class students, to mess around with that a little bit and see what goes on. And there are, like I said, a lot of examples in your book to help you. But essentially, when these are the same, you get a cardioid. If one of them is bigger, maybe you stretch it this way or you pull it in. When one is smaller, same thing. Ultimately, I was telling my students, it's kind of like a rubber band. When you're a kid, you play with the rubber band and it's circular. And you can kind of stretch it out and flatten it and twist it around. Here I kind of take the rubber band and I pull one side into a point to make it look like a heart. If I wanted, I could press that point out and make that side of the rubber band look almost flat. I can do that if I mess around with those two numbers. If I want, I can keep pulling the rubber band, and then if I do it enough, I can kind of loop it over and kind of twist the rubber band. And you get a little loop right in here where this point keeps on extending. Then you just twist it to get a little loop in there. And again, that is all based off of this A and this B right here. There will be examples in your book for you to go over. Here's a couple of basic ideas on how to graph these polar equations. If you have any other questions, feel free to stop by my office or email me or post something on Blackboard. Ultimately, since you guys are going to have access to your book during your exam, you don't necessarily need to memorize all the formulas for the different polar graphs. So all you really need to know is, if you're not sure what the graph is just by looking at the equation, how to take theta values, find the associated R values, and with those, plot points and connect the dots.